Welcome back, guys. Let me see what else is coming up. All right, so I'm going to kind of go over, it'll seem very repetitive because some of the things do overlap. I'm going to kind of go over some of these things. And you do want to understand. I'm going to get rid of this. And I'm going to bring this, these are the properties of the cosine function. Okay, I'm going to bring the cosine curve, which we have seen on our screen when we were working on Desmos. Okay, so guys, cosine function is even. The sine function is odd because it was symmetric with regard to the origin. The cosine function is odd. Give me 1 second, okay? Well, what does it mean for a function to be odd? No big deal. We're going to explain it. Okay, what's an odd function? Okay, sorry. Um, let's see what they're saying. This is even. This function is even. Okay, so let's write it down. This is even. What's an even function? Even functions are symmetric with regard to the y-axis. What does that mean? Well, this is easier. This is relatively easy to see. Take a look at the cosine function, okay? The left-hand side of the y-axis, symmetric with regard to the y-axis. The left-hand side of the y-axis is a mirror image of the right-hand side. If you fold this, if you print it and fold it along the y-axis, this side will fall on top of this side. That's how we know if a function is odd or even. If a function is even, it will be symmetric with regard to the y-axis. If a function is odd, like sine function is, it will be symmetric with regard to the origin. With regard to the origin is a little more difficult to see. You put one on top of the other, move it half circle. But with regard to y-axis, it's very easy to see. I can clearly see that this is the mirror image of this. I know my colors won't be the pink and black, they match. That's all I'm trying to say. So it's not that difficult concept. So basically that explains part three. The cosine function is even, symmetric of the and the symmetry of the graph with respect to y-axis. That's really what I'm saying here. Okay. Now, the domain, as we have said, is all real numbers, negative infinity, positive infinity. And the range is between -1 and +1, like we have shown before. We have shown it in the context of sine function and cosine function, so I'm not going to write it here because it's all here, okay? Now take a look, the cosine function is periodic. What was that supposed to mean? That means if you focus on 0 through 2 pi, it's repeated. Okay, if you focus on this much, this picture is just copied. Same, same. That's what we mean by periodic. And the period is 2 pi because after 2 pi, sine functions and cosine functions take the same value. X-intercepts, oh, easy. X-intercepts are these where the curve cuts the x-axis. And if you pay attention, you're going to see these are the ones I put a slash, pink slash through. All right. The next one, maximum value right here occurs at -2 pi, -2 pi, 0, 0, 2 pi. So all these numbers are here. You don't have to memorize this table. You don't have to memorize this picture. You will have access to it, but you will have to learn how to read it. And what is the minimum value? Here, -pi, right here. pi right here. And then the next one comes up at 3 pi and all that. So these are the properties you really want to understand of sine and cosine function. So I'm going to pause there a little bit. And again, I'm repeating myself. You want to know how to draw the graph. You have to know how to read the graph. You have to know the basic properties of the graph. Do you have to memorize them blindly? No. But when you have it in front of you, okay, if you don't know what it means, it's not going to help you. Okay, you have to know what it means. I'm going to give you guys a couple of minutes to see if you have any questions. We will go over one more concept in this chapter, and then we'll be ready for some of the problems. All right, guys. Some interesting properties, guys. Now, these are, I don't worry about cosine yet. It's going to work exactly the same way. What happens, guys, if I multiply the sine function by 2? You're going to see those. What happened? Take a look at it. One was like this, 2. It's called a vertical stretch. Okay? The maximum, the curve it goes up and down. What about 3? And this point, let's do 4. If you do it by 4, so it's called a vertical stretch. It seems like they're stretching the function up and down vertically. And this peak, the maximum value, how high is it from the x-axis, is called the amplitude. Okay, so we're going to write it here. We're going to go to a new slide. I'm going to show you a slide, a summary. I'm going to write down the word right now. It's called amplitude, a fancy word. Amplitude. Okay. What's the amplitude of a function? If you look at your curve, whatever coefficient you put here, generally, if there's nothing, it's a 1. That's how we generally draw it, right? The main basic function. But what if we multiply this by 2? It's called a vertical stretch. Multiplied by 3, it goes up to 3. Multiplied by 4, it goes up to 4. And this is called the amplitude. And what if you multiply it by -4? Interesting, isn't it? The amplitude is still 4. What about -3? It's still, the amplitude is the maximum peak. How high is it from the x-axis? The answer is still 3. If I do it 2, it's going to be still 2. -2 or +2 doesn't matter. Amplitude will be that. So here is a fancy slide that you want to be familiar with. All right, so you want to be familiar with this. Okay, so don't worry. This is a W-like letter. It's called omega, O-M-E-G-A. Don't worry about it too much. We have seen our sine function in the basic format. However, we can stick something here, omega. I don't have a good way of writing omega, but I'm going to write W. Or I can stick an A here. Now, this A, absolute value of A, means whether this A is positive or negative, that's going to be the amplitude. What is amplitude again? Amplitude is how high the maximum value is from the x-axis. So we have seen it here, and you can always play with it, right? You can always, even if you put 3.5, you're going to see this goes up to 3.5. Doesn't matter if it's minus or plus. Doesn't matter. Okay? And the things we are showing is kind of based on transformation of functions. Okay, it's called a vertical stretch. So let's go back. So basically, the amplitude is going to be whatever this number is, you find the absolute value. If it's plus 2, it'll be plus 2 amplitude. If it's going to be minus 2, it's going to be still plus 2 because you're going to find the absolute value. Now, the period part is a little tricky, but I will try to explain it to you. Okay, this why do we divide 2 pi by w? So let's be a little patient. Let's go back and start with the basic sine function, just the basic. I want you to see happens, what happens if you put a 2 inside the parenthesis. When you put a 2 inside the parenthesis, let me keep the original one here so that you can see it. This is the original one. Okay, take a look. It's a little hard, guys. Okay, let me keep the original one is the green one. All right, let me put that in dots so that you know it's not something we're focusing on. It's a point of reference. All right, so this is my original function. I can hide the sine 2x. What did it do? It is called a horizontal compression. What's a horizontal compression? Things are being pushed from right towards the y-axis and from the left towards the y-axis. Look at the red curve. It's like, let me see, it's like squished in. Everything is moving towards the y-axis by a factor of 2. Take a look. I have to explain it a little more in detail. So let me bring this guy here. Okay. What's happening is if the original period was 2 pi and you had this green piece that was being repeated, now in the same area, you have two of them. Look, one whole chunk, another whole chunk. So this is called a horizontal compression by a factor of 2. Horizontal compression because it goes like this, goes like this. Factor of 2 because my function was sine of 2x, and that's all they are trying to say. And it is hard concept, guys. It's a hard concept. So I'm going to hide this. So what they're trying to say, you take your 2 pi, the period of your original basic sine function, and you divide it by this omega, whatever factor you use. Okay? That's going to be your the period. All right? So I'll give you an example. So let's say I want you to find, I'm going to do a couple of examples. These are very similar to the ones you'll find in your book. All right, so I'm going to take y equal to 3 sine 2x. Okay, it doesn't matter if this 3 was a fraction, fine. If this 2 was a fraction, the same principle works. So I want to find the amplitude. The amplitude is going to be, I'm just going to write amp, is going to be absolute value of 3. Let's see how we can write absolute value of 3. Absolute value of 3 is what? 3. And how do I find the period of this function? The period is going to be, take the period of the basic sine function, which is 2 pi, and divide it by this coefficient. The coefficient, my coefficient is 2 divided by 2. That's the period. Okay, let me do one more for you guys. So let's say this is -4, and this is 2/3. Okay, so the amplitude will be the absolute value of -4, which is going to be 4. Don't write -4. It's going to be incorrect. Amplitude is always positive. And the period is going to be 2 pi, the main period, divided by 2/3. And what happens, guys, when you divide by a fraction? You flip and multiply. and this 2 and this 2 will cancel. Let me put it here. I actually have to put it here. This 2 and this other 2 in the bottom and 2 on top will cancel, and your answer will be 3 pi. 3 pi. Okay, that's how we find amplitude and period for sine and cosine function. Everything I said here is going to work for cosine as well. But I will show you one more example. Okay, actually, I'm going to show you this very same example. I'm going to graph the function and show you why the period is really 3 pi. Okay, so be a little patient. Don't forget this. This is 2/3 is the factor, and -4 is the coefficient here. So let's go back. Let's take our sine function, -4, and this one was 2/3. Now, what did we calculate? You don't even need this anymore. We calculated that the period was 2 pi, 3 pi, right? That's what our calculation showed us. Now, take a look at this. This is 2 pi, the unit that's being repeated. Okay, the left-hand side, the basic unit for this curve is this. And that is clearly 0 through 3 pi. So it's a way of checking your answer is correct. Okay. Now let's pause here a little bit to see if people have any questions. I don't have anything else to do, actually. The problems that you will do from this section, let me go back and check if I have assigned them already or I have to assign them. Let me go back and check, guys. This is 2.4, and you can always interrupt me, okay? 2.4, I may have. Yeah, 2.4. You should be able to do them, guys. I think 2.4 problems are relatively easy. They're based on the graphs, and you know how to graph them, and you know what everything, all the little bits and pieces, what they mean. Like you know what those boxes mean right here. So basic main concept is amplitude and period from 2.4 and knowing the properties of sine and cosine function. That's all. They're periodic, what the domain is, what the range is, what the x-intercepts are, what the y-intercept is, so on and so forth. Okay? Any questions, guys? Any questions from anyone? Try some of these problems. I don't believe you guys will have a lot of trouble with 2.4. They're very straightforward. Learn to organize your notes. Keep things handy when you do the homework problems. And I'll be happy to help you if you have any other questions, guys. So we wrapped up 2.4, okay? It seems like we haven't done the problem. We actually did. When you do the problem, you'll see many of those things were done. I kind of made up the problems. If you have any trouble, if you have trouble with any of the questions, just holler, just email me. So I'm going to wrap up now, guys. I'm going to get out of this session. I'm going to come back and I will be available for the next 35 minutes. And I'll be doing things on the computer, uploading your videos and looking at your assignments and all those things. But feel free to stop by if you have any questions. Thank you, guys. If you don't want to come, I will see you next class. Take care. Bye-bye.